Today I will be discussing about rock cycle. This is a topic in the course Petrology and the course code is BGYCT 135. I am Professor Bhaskar from Geology discipline, School of Sciences, IGNOU. So, let us see about the rock cycle. The outline I will be discussing will be what are rocks, what are the different types of rocks, what is a rock cycle, how rock cycles and plate tectonics are related, how rock cycles and geological environment are related, and finally, I will give a summary of the presentation. Now, all of you must be familiar with the term rocks. Rocks is nothing but a coherent, naturally occurring solid comprising aggregate of minerals. There are two terms you must have encountered, outcrop and incrop. Outcrop is when the portion of the rock appears at the surface, and incrop is when rocks are not exposed on the surface. Now, just to give you an example, please see the slide. I will tell you what are the minerals that can be seen in a granitic rock. If you take a hand lens, you can clearly identify hornblende, plagioclase, muscovite, potash feldspar and quartz. Based on the physical appearance, you can distinguish these minerals. And in the just to give you the term petrology, what is petrology? Petrology is that branch of geology which deals with the study of rocks. People misinterpret, if you are not aware, it may be related to something like petroleum. No, petrology means study of rocks. And a petrologist is one who studies rocks, identifies minerals present in them and makes observations. Now, broadly, you are all familiar, there are three kinds of rocks. One is an igneous rock, which is made from a molten or partly molten magma. They are also called as primary rocks. Sedimentary rocks are also called secondary rock. They are made from the pre-existing rocks. They may be igneous rocks, sedimentary rocks or metamorphic rocks. When they break down due to mechanical and chemical weathering and when they get consolidated, they give rise to sedimentary rock. The third type of rock is metamorphic rocks. They are the pre-existing igneous, sedimentary or metamorphic rocks which undergo mineralogical, chemical and structural changes. Metamorphism means there is a change from the original composition, structure of the rock. The composition can be the same. Now, if you see this diagram, I have given three examples. If you see the figure, one is a granite, which is an example of igneous rock. Two is a sandstone, it is an example of sedimentary rock. And three is phyllite, which is an example of metamorphic rock. Now, let us see the word igneous rock. It is derived from the Latin word ignis. Ignis means fire or to ignite. Now, they are formed because of cooling and crystallization of hot molten material magma. Magma can be derived from melting of pre-existing rocks, and these rocks can be in the crust or in the mantle. The melting of rock process occurs because of either increase in temperature or decrease in pressure or a change in composition. Now, igneous rocks can be of two types. One is intrusive igneous rocks and second is the extrusive igneous rocks. Plutonic rocks crystallize when magma cools in deeper conditions or magma chamber or intrudes the country rock or the host rock. They are called intrusive igneous rock. Examples are granite, granodiorite, gabbro, diorite. Now, extrusive igneous rocks are volcanic rocks. They are hot, partly molten rock material. The lava moves out of the earth's surface and it cools rapidly because of contact with water or air. Examples are basalt and rhyolite. And the plutonic rocks, as the term says, it undergoes cooling and consolidation beneath the surface of the earth and occurs as intrusive bodies. For example, Mount Abu, you have the rocks, Ladakh batholith, they are all plutonic rocks. Volcanic rocks are that which undergo cooling and consolidation at the surface of the earth, and it comes in contact either with the air or water, and they are like lava flow. Examples are famous Deccan basalts or Malani rhyolites. Now, what are hypabasal rocks? They are somewhat intermediate in the sense they undergo cooling and consolidation at the shallow level or near the surface of the earth. For example, the rock dolerite is an example of this. Because they are neither very deep nor coming to the surface, they are medium grained and occur often as dikes or sills. Now, see this figure, you have plutonic rock, it is formed below the earth, it is coarse grained granite. Volcanic rock, it is fine grained because it is in contact with air or water. By rapid cooling, you get the basalt, and the intermediate rocks which are formed are medium grained hypabasal rock like dolerite. Now, the typical igneous rocks which you can encounter are granite and pegmatite and rhyolite. There is a difference in the grain size. Rhyolite is fine grained, granite is coarse grained, and pegmatite contains different grain sizes. The second type of rock is known as sedimentary rocks. They are formed from the decomposition and disintegration of pre-existing rock. Decomposition means composition change, disintegration means mechanical breakdown. And the pre-existing rocks may be igneous, may be sedimentary, or even may be sedimentary rocks itself. And they are produced by the process of weathering. As you know, weathering can be physical, chemical, biological. They can be also by agents, geological agents such as wind, river, water, glaciers, oceans and groundwater. There are basically two types of sedimentary rocks. You can classify them as clastic or detrital. Then second one is chemical. In the chemical, you also have a classification which is biochemical. Clastic or detrital means the made up of mechanical weathering. Chemical means there is some chemical precipitation, inorganic precipitation or evaporation. Biochemical means some life is involved, organic remains, shells, charcoal, plant fragments. These are the types of sedimentary rock. Now, let us come to the clastic sedimentary rocks. They are also called as terrigenous rocks. Now, these comprise siliclastic sediments which are made up of physically deposited particles such as grains of quartz and feldspar derived from pre-existing rock. So, these are nothing but the mechanical breakdown which has occurred. Now, non-clastic means they can be chemical form, they can be biochemical, they can be biological involvement of material which is there. For example, you can have halite is a chemical sediment that precipitates directly from evaporating seawater. If you have limestone, then you have the life formation which can be involved. Now, two examples are given in the figure. If you see that, one clastic which is coarse and medium grained sandstone, and non-clastic is limestone. Now, what is the difference between the two? The sandstone is formed by mechanical weathering and subsequent processes. The non-clastic limestone is normally the chemical or the biochemical process which are involved in their formation. Then you have the different type of sedimentary rocks based on the minerals size and shapes, conglomerate and breccia. In breccia you can have the angular fragments, and conglomerate you will have rounded fragments and they are larger in size. Now, you can also have sandstone which can vary in size, grain size from medium to very coarse, and this is a field diagram in which a rock is exposed which has thickly bedded ferruginous sandstone. So, you can see that the classification is done based on the grain size also. You can have a medium grain sandstone, you can have a coarse grain sandstone. Now, these are another two examples of sedimentary rock which are fine grained. For example, red colored massive shales, they are fine grained. Then you have different shale which is light brown colored showing ripple marks. These are fine grained. These ripple marks can be caused either due to water action or wind action, and normally they give an idea of the environment in which they are formed. The next type of rock is metamorphic. So, learners, you must be clear that there is igneous rock formed from magma, sedimentary rock formed from pre-existing rocks either by mechanical breakdown or chemical. There is a third category which is metamorphic rock. They are also formed from pre-existing rock, but the difference is that these rocks are formed without melting. That means the pre-existing rock or protolith undergoes a solid state change in response to elevated temperature and pressure in the presence of chemically active fluid. And the word Greek word meta means change, morph means form. So, metamorphic rock is different from sedimentary rock in the sense that there is no, it is a solid state change. In case of igneous rock, melting took place, and in case of sedimentary rock, breakdown or chemical precipitation took place, and in case of metamorphic rock, it is a solid state change. The same material, when you subject them to different pressure or temperature conditions, the material may become different. Let us now see what is this. Now, it is an isochemical process. That means the bulk composition of a rock body is more or less unchanged from the protolith or original rock. That means if you take a metamorphic rock and its parent rock from which it formed, the bulk composition will be same, but the texture will be different. That is how we identify the metamorphic rock. That is why we cannot only rely on chemistry. It is also important to understand the petrography, the thin section study, and the interrelationship, the textural and structural relationship which are important. Now, if you see the granite, if you subject it to the changed pressure temperature conditions, it will be transformed to schist during the process of metamorphism. If you analyze these two rocks, the composition may be same, but the texture will be different. That is important. Similarly, limestone and marble have the same composition, but marble is a stronger rock because metamorphism has occurred. Limestone weathers very fast, and if you see, most of the monuments are made up of marble because they are able to withstand the weathering process. Now, sandstone can be again metamorphosed to quartzite. Composition is same, but the arrangement of grains is different. Now, there are three examples of metamorphic rock. One is a slate which is plain, second is phyllite you can see, and third is schist. These are the three different kind of rocks which are there in the metamorphic rock. Now, all these three are formed under different pressure temperature conditions, and that is why there is a change in the grain size. Sometimes there is foliation, sometimes it gets arranged in the form of sheets, and all these things are because of the different temperature and pressure conditions which are involved. Now, there are another three examples which are given is of gneiss. You can see again they are white and black bands, you can see them. Then quartzite again formed from sandstone, marble which is formed from limestone. So, the same rock when you subject them to changed pressure temperature condition, the mineral grains rearrange themselves and result in different kind of rocks. That is how metamorphic rocks are formed. Now let us come to the example. What we have discussed is the rock cycle is important. You must have seen that one type of rock changes to another type of rock. A sedimentary rock can become a metamorphic can become sedimentary, igneous can become sedimentary. So this is a cycle, that is why it is called a rock cycle. That is nothing but a sequence of events involving the formation, alteration, destruction and reformation of the rocks. Now rocks can change over time through the rock cycle because of the changed external or internal conditions. The rock cycle doesn't go only in one direction, that is why it is called a cycle, and any rock can go through any part of the cycle through many times. That is very important for us to understand. The rock cycle explains how rocks and natural processes are related. What are the natural processes? Weathering, melting, changed pressure and temperature conditions, heat. So these natural processes result in change of the rock, resulting in the rock cycle. James Hutton was the person in 18th century who developed the concept of rock cycle to show how rocks and natural and physical processes are interrelated. So you can see how this was explained by James Hutton. Now the question that may come to your mind is, where is the energy for all these processes? Solar energy is a driving force, gravity is a driving force, radioactive heating is a driving force for the rock cycle. Inside the earth there are radioactive elements and the heat is generated that causes melting. The solar energy is important because sun's rays fall on the earth and differential heating takes place. There is movement of wind, water, all those things which are resulted in the external process. You have the endogenic process and the exogenic process. As a result, rock cycle will be self-sustaining for thousands of millions of years because the radioactivity has a long life. So long as heat is there, it will keep on occurring and this cycle will occur. So long as sunlight falls, there will be external changes which will take place and that will result in the rock cycle. So this is what we have to understand. Now rock cycle depicts changes in the way the three types of rocks, sedimentary, metamorphic and igneous, change over geological time. When a rock type is pushed beyond its equilibrium, it undergoes changes. Now in a way, I can put it in simple way that the rock tries to adjust itself with the new environment, changed physical and chemical conditions, and inside the rocks the minerals which are there, they get altered in the process, giving rise to new or different rock types. Now for example, an igneous rock like basalt that is subducted beneath a continent may melt, okay, or if it is exposed in the atmosphere, it will be disintegrated because of that. Because of plate tectonics, water cycle, rock cycle, the rocks are constantly changing and adapting to their new surroundings. You should also remember the water cycle is taking place because of the solar energy. The water cycle also plays an important role in conducting the rock cycle. Now the rock cycle is because of the plate tectonics, and water cycle helps in weathering and breakdown of these rocks. So you can see all these are related. Now the relationship between the three types of rocks and the way in which the process over time vary is explained by the rock cycle. Because of this cyclical nature, what happens? Rock alters both, that is important, and also life also has an impact on the rock cycle. That is why the biogeochemical cycle on the planet where life exists and the geological cycle. So you can see in certain cases life forms also result in some of the processes taking place in the sedimentary rocks. For example, you can have coal, you can have limestone, all these kind of things. Now, if you see this diagram here, you have the igneous rock, which is formed from molten lava, and these rocks, when if it comes out, it becomes lava. If it is solidified below the earth, then it becomes igneous rock. Then when they are weathered, they become the sedimentary rock, and when the sediments get deposited because of geological agent, they become sedimentary rock, and when these sedimentary rocks get metamorphosed or igneous rocks get metamorphosed, you have the metamorphic rocks. The metamorphic rocks can again melt to give magma, which can give igneous rocks, or metamorphic rocks can also break down to form sediments, and they can form the sedimentary rocks. These fragments, and these can form the sedimentary rocks. So, basically one type of rock can be converted to any type of rock, and any rock can convert directly to any rock. There is no sequence that it has to be igneous, sedimentary, metamorphic. Igneous can be metamorphic, metamorphic to sedimentary, sedimentary to igneous. All these are possible. So, you can see the complete cycle. The mantle, crust and the surface of the earth can be thought as a giant recycling machine, and the rocks are neither created nor destroyed. What is actually happening is the material which is there is redistributed and transformed from one form to another. This transformation, this movement requires energy, and as I said to you, the primary source is the radioactive energy which is there. It is also the gravity, it is also the sun's energy for the external processes which take place. Now, rocks are created and changed because of plate tectonics and the processes which occur on the surface of the earth. Now, plate tectonics drives the rock cycle, the movement of the rocks and the minerals that comprise them and the chemical elements that comprise them move from one reservoir to another. This is the way the rock cycle occurs. Rock cycles are indicators of the geological environment. The questions which you should be wondering and asking is what type of environment are characterized by the process that produce the igneous rocks? What type of environment are preserved by the accumulation of sediments? And the third question can be what type of environment are characterized by the tremendous heat and pressure that produces metamorphic rocks. So, different geological environment characterize these features and they result in these kind of rocks. Now, let me summarize quickly that igneous rock is a rock that is solidified from hot, molten or partially molten material called magma. Igneous rock may be intrusive or extrusive depending on whether they come out of the surface or they get consolidated, they get below the surface. Based on the mode of occurrence, igneous rocks may be plutonic inside the earth, volcanic outside and hyperbosal intermediate. Sedimentary rocks result from the consolidation of the loose sediment or chemical precipitation from solution or organic rock consisting of secretions or remains of plant and animal. For example, coal. Sedimentary rocks can be mechanically formed from clastic rocks. They can also be formed chemically by non-clastic rocks. I gave you example of halite. You can also have limestone. Metamorphic rock is the rock which is derived from recrystallization of pre-existing rock either by mineralogical, chemical or structural changes, and these changes are in response to temperature, pressure or chemically active fluids at the depth of the earth's crust. Rock cycle in a way is a continuous process and is closely tied up with the plate tectonics. Rock cycle starts with the cooling and consolidation of the magma derived from the mantle, which are subsequently exposed to the atmospheric agencies to form sedimentary rocks under normal temperature and pressure or metamorphic rocks under increased temperature and pressure. Just a last slide to show to you rock types can be igneous, sedimentary or metamorphic. What are the minerals? You can see granite, sandstone and phyllite. You can see the mineral sources. You can see the rock forming process which is explained, which are clearly given in these diagrams. So, I am sure learners, you should have understood by now the difference between igneous, sedimentary and metamorphic rocks and what drives the plate tectonic cycle. Thank you very much for the patient hearing. Thank you.